Hello dear students, very good morning to all of you. Dear students, here we are discussing the chemistry of noble gases, and in that we have learned about the compounds of xenon. Xenon is mainly forming three types of compounds. These are xenon fluorides, xenon oxides and xenon oxyfluorides. Means when xenon is combining with the oxygen and fluorine in different proportions, it is forming xenon oxides, fluorides and oxyfluorides. In last video we have discussed about the xenon fluorides. Today let us discuss about the xenon oxyfluorides. Xenon combining with oxygen and fluorine mainly forms 3 to 4 types of compounds, and these are xenon oxy difluoride, xenon oxy tetrafluoride, xenon dioxy difluoride, then xenon trioxy difluoride, and some ions will be formed, and one of the example is xenon oxy pentafluorate, xenon oxy pentafluorate anion. Okay, so we will see one by one the preparation methods and the structures of these xenon oxyfluorides. So first one is xenon oxy difluoride. Okay, the formula is XeOF2. So how will you prepare this? Very simple. Let us start with xenon tetrafluoride. Xenon tetrafluoride, when hydrolysis of this xenon tetrafluoride is done at low temperature such as minus 80 degrees Celsius, then you will get xenon oxy difluoride. Xenon oxy difluoride, Xe as it is, O as it is, F2. Okay, so in the reactant side there are 4 fluorine atoms, and on the it is also having 2 hydrogen atoms. So out of 4 fluorine, 2 fluorine comes in the xenon oxy difluoride. So 2 fluorine are remaining with 2 hydrogens. So side product is twice HF. Okay, hydrogen fluoride is the side product. So in this way xenon oxy difluoride can be prepared by using xenon tetrafluoride. Okay, now the structure. So the structure of this xenon oxy difluoride can be studied, can be explained on the basis of VSEPR theory. Okay, valence shell electron pair repulsion theory. Okay, so and it is also explained on the basis of VBT, that is valence bond theory. Okay, so the central atom in this case, central atom. So how will you choose central atom? The least electronegative, the atom which is having least electronegativity can be considered as a central atom. Okay, so in this case the central atom is xenon, having least electronegativity because oxygen and fluorine have more electronegative atoms. Okay, now the outermost electronic configuration of this xenon is 5s2, 5p6 and 5d0. Okay, so this is outermost electronic configuration, as xenon is belonging to 5th period, so its outermost electronic configuration is having 5th shell. Okay, so we can dictate this with the help of orbital diagram. So this is 5s2, then p subshell is having 3 orbitals, all are fulfilled. Okay, and d subshell is empty, 1 2 3 4 and this is 5. D subshell is empty. Now this ground state xenon is undergoing excitation, and hence the excited state electronic configuration will be like this. So this electron get this electron and this electron from the p subshell, they are getting excited to empty d orbital, and hence our configuration will become 5s2 5p4 and 5d2 1 2 3 4 and 5. Okay, so now we have two electrons in d orbital, so one s 3p and 1d, 1s 3p and 1d orbitals get hybridized together, and hence we can write hybridization. So hybridization is sp3d, s3p and 1d, sp3 hybrid orbitals, and they are forming sp3 hybrid orbitals. So we can 1 2 3 4 and 5, 1 2 3 4 and this is 5. So out of these 6 orbitals having electrons, only 5 orbitals get hybridized together, leaving behind one orbital with unhybridized state. So this is the d orbital with unhybridized d orbital. Okay, so this is sp3d hybrid orbitals, 5. Out of them one is having lone pair of electron, 2 of them having lone pair of electron, and 1 2 and this one is third. Okay, so out of these sp3d hybrid orbitals, the 2 orbitals are having paired electrons and 3 orbitals are having unpaired electrons, single electrons. Now we have, this is all about xenon. Now we have 2 fluorine and 1 oxygen atoms. Okay, so the 2 fluorine atoms, I am showing the cross electrons of fluorine by cross. Okay, so they get shared, the electrons of fluorine are get shared, single electrons are get shared by the xenon orbital electron. Okay, sp3 hybrid orbital electron. Okay, so 2 fluorine atoms. Okay, as well as there is a presence of 1 oxygen atom. So this oxygen atom is forming 2 bonds here. One is sigma bond with, I am showing it by dotted arrow. Okay, so this is oxygen atom, it is forming sigma covalent bond, and this is unhybridized orbital of xenon, so it is forming a pi bond. So both these bonds are formed by the oxygen atom. Okay, one is sigma and another is pi bond. Now this is sp3 hybrid orbitals. Now we will count the number of bond pairs. So now how many number of bond pairs are there? 1 2 3. So 3 sigma bonds are there, 3 sigma and 1 pi, 3 sigma and 1 pi bond is there. Now number of lone pairs will be 2. Okay, so 2 lone pairs. So while counting the steric number, we are only considering the sigma bonds. So sigma bonds and the 2 lone pairs, the steric number will be 5. And as steric number is 5, the expected electronic geometry of the molecule XeOF2 will be trigonal bipyramidal. This is expected electronic geometry as per the VSEPR theory. But while dictating the shape of the molecule or the molecular geometry, we are considering only the bond pairs, we are neglecting the lone pairs. Okay, so out of 1 2 3 4 5, okay, the arrangement of these electron pairs will be like this. So this is central xenon atom, and this is first lone pair, second lone pair. Okay, fluorine and this is oxygen. Okay, so axial positions are occupied by the 2 fluorine atoms, and the triangular base is occupied by 2 lone pairs and one corner is occupied by the oxygen atom. Okay, so this is known as trigonal bipyramidal. 1 2 3 4 5 trigonal bipyramidal. But actual shape of the molecule, we are neglecting these lone pairs, so it is looking like a T shape. It is looking like a T shape. Okay, or we can say that this is the central xenon atom at my fingers. This is one fluorine, second fluorine, and this is the double bond oxygen. My chalk is showing the bonding with oxygen and xenon. Okay, so this is the shape of the molecule. We call it as a T shape of the molecule. So shape or geometry of the molecule is T shape. Okay, so this is actual shape of molecule, actual geometry of the molecule. We can call it as a molecular geometry. Okay, so this is all about the Genonoxy difluoride. Okay, now the second one is called Genonoxy tetrafluoride. Genonoxy tetrafluoride. XeOF4 tetra, Genonoxy tetrafluoride. Okay, how will you prepare this Genonoxy tetrafluoride? Simply take xenon hexafluoride, do hydrolysis of that xenon hexafluoride, okay, and at ordinary temperature it will give XeOF4 plus twice HF. Very easy to remember. Only replace tetrafluoride by hexafluoride at the starting and you will get XeO. There are 6 fluorine atoms, out of which 4 coming in the product. 2 fluorine atoms remains, they combine with 2 hydrogens forming twice HF. Okay, again the structure will be same and can be explained in the same manner that we have explained for that of XeOF2. Okay, central atom is xenon, outer electronic configuration, then excitation, then hybridization. Okay, so what are the changes that I am only explaining you. Okay, so in this case all the 6 orbitals, out of the 6 orbitals, 3 out of the 6 electrons in the 5p orbital, 3 electrons are get shifted to the empty d orbital. Okay, so this electron shifted here, this electron get excited here, and this electron is also get excited to here. Okay, so my situation will be, we have to remove this electron and put this in the empty d orbital. Okay, so my configuration will be so here we have one completely filled s orbital, 3 completely half filled p orbital, and 3 electrons in the d orbital. So 1s 3p and 2d, 1s 3p and 2d orbitals get hybridized together. So my hybridization is sp3d2, leaving behind one orbital unhybridized state. Okay, so this is the situation. Now what I am changing to here, only 4 fluorine atoms. Okay, so this is oxygen, this is also fluorine, this is also fluorine, and this is oxygen, and this orbital is having, this is in empty d orbital, it is forming a pi bond with oxygen, which is shown by a dotted line. Okay, so dotted lines means these are the 2 electrons from oxygen atom. Okay, one is forming sigma and another is forming pi bond. Okay, so pi bond is formed by the unhybridized orbital of xenon with oxygen atom. Okay, and there are 4 fluorine atoms, 1 2 3 4. The electrons are shown by cross fluorine electrons. Okay, so this is the situation, and only one lone pair of electron is there. Okay, so number of bond pairs now 1 2 3 4 5 5 sigma and 1 pi, 5 sigma and 1 pi bond is there. Okay, so and lone pair is only 1, lone pair is only 1. So 5 plus 6, what is the sum? 6. 5 plus 1, 6. Okay, so the steric number is 6 according to VSEPR theory. So when steric number is 6, the expected geometry is octahedral. Expected geometry is octahedral. We are familiar now with this octahedral geometry. So we are trying to draw the octahedral geometry of this XeOF4. Okay, and the geometry will be like this: central xenon atom with 4 fluorine atoms taking a place of four corners of a square planar. Four corners of a square planar. Okay. So this is a base, what we call square planar, four fluorine atoms, and one oxygen atom is there. So it is taking a axial position. It is taking a axial position. Okay. But expected geometry is octahedral. One lone pair is remaining. So put this lone pair at the another axial position. So this is lone pair. Okay. So this molecule is looking like a octahedral shape. Okay. But actual geometry or shape of the molecular geometry is square pyramidal. Square pyramidal. How will you obtain this? Square pyramidal. So this is a square and this is only a one bonding is present at the top. So it is a square and it is like a pyramid. Square pyramidal. Okay. So neglecting this lone pair, so the geometry will be square pyramidal. Okay. So this is all about the XeOF4, that is Genonoxy tetrafluoride. Okay. Now the last molecule, next molecule is the XeO2F2. XeO2F2. So Xenon dioxy difluoride. Xenon dioxy difluoride. Okay. So the preparation of this Genonoxy Xenon dioxy difluoride will be from XeOF4 and XeOF4, that is from this molecule. XeOF4 react with this water, it is forming XeO2F2 plus twice HF. Okay, so from this molecule we are preparing this molecule XeOF4 reacting with water, it is forming XeO2F4. Okay, you can try by your own all these things. Okay, I am explaining only here the hybridization and the geometry of the molecule. Okay, so in this case the hybridization is again sp3d. Hybridization is sp3d. Okay, sp3d hybridization. Okay, so how many orbitals are combining? 1, 2, 3, 4 and 5. Okay, 5 orbitals are there. And now expected geometry of the molecule is trigonal bipyramidal, as steric number is 5, sp3d. Okay, and we will try to draw the structure of this F2 here, XeO2F2. So central xenon with 2 bonding with oxygen, fluorine, and this is the lone pair. Okay, so 2 oxygen occupying 2 corners of a regular triangular base of this trigonal bipyramidal shape, and the 2 fluorine atoms are taking position of axial position, and one of the lone pair is present in this case, and it is taking the one of the triangular face or one of the triangular corner. Okay, so this is a trigonal bipyramidal, looking like a trigonal bipyramidal expected electronic geometry. But neglect this shape, you will looking like this. So it will look like this. Okay, so this is central xenon atom in my fingers. Okay, this is one fluorine, another fluorine, and 2 oxygen atoms, they are like this. So this is the shape of molecule. Okay, xenon, fluorine, and 1 oxygen, second oxygen. So this is a lone pair. Neglect this lone pair for the actual shape of molecule. Okay, how will you looking like this? I am tilting it just like this. Okay, so actually it is present like this. I am tilting it like this. Okay, so how it is looking? It is looking like a seesaw. That we are playing in the garden. Okay, so seesaw are placed in the garden to play for the little children okay, and this is the shape of the molecule, seesaw. So in my fingers I have taken the xenon atom, fluorine with 2 oxygens with shown by 2 chalks. So this is the seesaw structure of the molecule, okay. So we can write here the shape of the molecule is seesaw, seesawed, okay, seesaw structure, okay. Now the next one is XeO3F2, okay, XeO3F2. What is the structure of this? Come to the structure directly. XeO3F2. So 2 fluorine atoms are as it is. So add only 1 oxygen atom. So replace this lone pair and put a oxygen atom. Okay. Now the expected geometry and the actual geometry, that is shape of the molecule, both are same, and that is trigonal bipyramidal. Trigonal bipyramidal. Both are same, okay. Now 0 lone pairs are present, no lone pair is present in this molecule. So XeO3F2 molecule is trigonal bipyramidal. Next one is XeOF5. So central xenon atom and 1, 2, 3, 4 and 5. 5 fluorine atoms, 1, 2, 3, 4 and 5. 5 fluorine atoms are present at the regular pentagon, 1, 2, 3, 4, 5, okay, regular pentagon central. There is a xenon atom, at the center place, okay. So this is xenon atom, 1, 2, 3, 4, 5, okay, and 1 oxygen atom is there. So this is taking place, oxygen atom is taking the position of top, okay, and hence as well as there is a presence of 1 negative charge to this anion. So we can write this, that the structure of the molecule is pentagonal pyramidal. Pentagonal pyramidal. This is the shape of molecule, pentagonal pyramidal, okay. So such structures can be asked in your examination for the drawing or identifying, okay. Now these are Genonoxy fluorides. Now we have to consider about xenon oxides. Xenon oxides. Xenon oxides. So XeO3 and XeO5. All the explanation regarding these structures, how the structures can be determined for XeO3 and XeO4, xenon trioxide and xenon tetroxide is can be explained on the basis of VSEPR theory as well as VBT theory, okay. So this xenon trioxide, the preparation can be done by using XeF4, okay. So xenon tetrafluoride, when it is reacting in a proportion of 3:6, okay, there is a formation of 2 xenon plus XeO3, okay. So 3 xenon atoms are there. Out of these, one is forming 2 xenon atoms and another xenon atom is combining with oxygen to form XeO3 plus formation of 3/2 O2, okay. 2 get cancelled, 3 oxygen remains. So 6 oxygens are there, 3 are combining with xenon forming trioxide and they are forming 3/2 O2. This is a balanced chemical reaction for the formation of xenon trioxide, okay. Now structure. This structure of the xenon trioxide is very easy. Central atom is xenon. It is forming 3 bonds. It is forming 3 bonds with 3 oxygen atoms having 1 lone pair of electron, and that lone pair of electron taking a position of apex, okay. So the hybridization is sp3. Hybridization is sp3 for central xenon atom, and hence expected geometry or electronic geometry is tetrahedral. But neglecting this lone pair, the actual shape of the molecule or molecular geometry is just like ammonia, central nitrogen with 3 hydrogens and the lone pair at the apex, it is pyramidal. It is pyramidal. Okay, so this is the structure of xenon trioxide. You can try to solve this xenon trioxide structure explanation by your own. Okay, just I have explained for the remaining previous examples. Okay, so this is xenon trioxide. Now what is the change only for tetroxide? Replace this lone pair at the top and by a 4th oxygen, so you will get xenon tetroxide. 1 2 3 and this is 4. Okay, so this is a actual geometry and expected electronic geometry, both are same. Okay, and that is tetrahedral. That is tetrahedral. Central xenon atom is undergoing sp3 hybridization. Okay, and the shape of that molecule is like this. So this is central xenon atom, black ball in my hand. Okay, so this is central xenon atom. 1 2 and 3, these are 3 oxygen atoms. Okay, and the 4th one is at the top. So this is a structure of a regular tetrahedron in 3 dimensions. Okay, you can easily judge yourself, that is how is the structure of this xenon trioxide. It is tetrahedral, and when we replace this top oxygen atom, it is xenon trioxide XeO3. It is looking like a pyramidal shape. It is looking like a pyramidal shape. Okay, so both structures are very easy to understand. This is the total discussion of Xenon Oxyfluorides and Xenon oxides. Okay, so very easy to understand. So in this way we have covered and wind up all the concepts in the noble gases chapter. Okay, thanks for watching this video. Have a nice day.